So original equation for a linear differential equation is of this type: a n dn minus 1 upon dx raised to n minus 1 plus a n minus 1 d raised to n minus 1 upon dx raised to n minus 1 plus up to a1 dy by dx plus a naught y equal to f of x. So if you compare these two differential equations, what is the difference in both of them? What is the difference? Can you spot the difference?
Sir, in one there is no x raised to the power n.
Hmm. So this is a very important difference because in this, what we were saying was this is a linear differential equation with constant coefficient. So what do I mean by coefficient is d raised to n y upon dx raised to n minus 1. Whatever is with it, this term is called the coefficient. And in the definition of the differential equation, linear differential equation, these were the constants. So all the coefficients were constant. So the method, what we learned till now, those methods are applicable only for the linear differential equation with constant coefficient. But what if you don't have this constant coefficient? So in this Cauchy and Legendre, it is still not generalized. I mean, we cannot say that generalized linear differential equation with constant coefficient, but these are of the type where the coefficients are not constant. Those are variables here, and it is not arbitrary variable. It is of the form x raised to n, x raised to n minus 1, and so on. Such a differential where, let me just complete the definition, where an, an minus 1, so on up to a naught are constant is called Cauchy's linear differential equation. Okay. So in the given linear differential equation, your coefficients are variable, and those are not any variable. It is of the form x raised to n, x raised to n minus 1, and so on. So what do we do now? Our methods that we have studied till now are not applicable over here since your coefficients are not constant. So what we do is we make some substitution in this. So to solve this type of differential equation, we have a standard method, and the method states that you convert this differential equation to a differential equation with constant coefficient. And how do we do that? We do that by the substitution. We put x is equal to e raised to z. Okay. The moment we put x is equal to e raised to z, all these terms are going to change. dy raised dn raised to y upon dx raised to n minus n, dn minus 1 y upon dx raised to n minus 1, dn minus 2 y upon dx raised to n minus 2, and so on. So we need to make all the changes over there. In this, as you can see, the variable y is dependent and dx is independent variable. So in order to replace dy by dx, what I will do is I will differentiate this with respect to y. Also with this, I have to write that z is equal to log x. So put this in differential equation, in linear differential equation. Okay. And second step is differentiate with respect to y. So when we differentiate this x is equal to e raised to z with respect to y, what do we get? dx upon dy. Uh, Samarjit, is the screen still going black and again visible? Or it
Yes,
is
sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
okay? Wait a Okay, now
No, sir.
It's clear, sir.
okay. So dx by dy will be equal to derivative of e to the power z will be e to the power z by chain rule dz upon dy. So I can make
Sir, it's happening again.
okay. I hope it is not happening. So I want to replace dy by dx. So I'll take the reciprocals on both the side. So I will have dy by dx is equal to 1 upon e to the power z dy by dz. And send this e to the power z, which is nothing but the value of e to the power z is x. So what have we got? X into dy by dx is equal to dy by dz. Is this relation clear to everyone? So this look at the linear differential equation. This term will become dy by dz. Okay. Also on the right hand side, what I have done is I have substituted x as e to the power z. So this term will become f of e to the power z. It means that your differential equation will be converted to a new variable, and that will be in terms of z. Similarly, I can substitute this once again, and what I can get is third one x square d2y by dx square. If you substitute differentiate this term once again, what we will get is we will get x value for x square d2y by dx square. Okay, and in that case, what we will get on the right hand side is d by dz bracket d by dz minus 1 of y, which is if you open the bracket and d2y by dz square minus dy by dz. For remembering purpose, you simply remember this relation. Okay, and with this, so this term, the term after this we have replaced by d into d minus 1. Similarly, now you can guess what will happen for d cube y by dx cube. I'll rub this from here and write it at this position. So x into dy by dx is equal to dy by dz. This is our substitution. Okay. So can you guess? Can you go one step ahead and guess what will happen for x cube d cube y by dx cube? So that will be d by dz, d by dz minus 1, d by dz minus 2, bracket complete, y. Okay, so this kind of changes will happen, and all these terms x will get removed completely from that coefficient part, and we will originally get a linear differential equation with constant coefficients. I'll just write down the fourth point. So you will clearly understand what we will be doing. So fourth point is, after substituting
सर तुमचा व्हॉइस लॅग होतोय.
substituting x is equal to e raised to z, replace x into dy by dx x into d as d. X square d square will be replaced by d into d minus 1. X cube d cube is replaced by d minus 1 d minus 2. X raised to 4 d raised to 4 will be replaced by d minus 1 d minus 2 and d minus 3. Okay, and so on. You can actually guess what will happen for x raised to n. So after we substitute this, we'll make this replacements, and we get linear differential equation with constant coefficient. Once we get a linear differential equation with constant coefficients, we can apply our regular method. Okay. So once we are clear with this, we'll quickly go for an example which will make us understand this better.
सर तुमचा व्हॉइस लॅग होतोय.
आता
तुमचा व्हॉइस लॅग होतोय सर.
खूप लॅग होतोय का?
हो सर.
हो सर.
हो सर, लॅग होतोय.
आता नेटवर्क इश्यू असल्यामुळे मी आता मोबाईल डेटावरती केलंय, आधी वायफाय वरती होतं. अजून वेगळं नेटवर्क नाही काही करू शकत त्याच्यात. एनिवेज, जर काही खूपच प्रॉब्लेम येत असेल तर बघू मग तुम्ही YouTube वरती बघून घ्या लेक्चर. Because I don't have any other choice now. Okay, sorry for this, but we are all in same situation. ठीक है आनंद. आनंद,
हा येस सर, आत्ता येतोय आवाज.
ओके. Is the screen visible?
Yes, sir.
Okay, go ahead then. Square d2y by dx square minus 3x dy by dx plus 5y is equal to x square sine of log x. Okay. Remember that this is one of the silly mistake that has been observed every time, and the problem is you don't replace it on the other side. So when we make some change or substitute it on the left hand side, you also make the change on the right hand side. Okay. So once we have this, identify this. Okay, this is a Cauchy's linear differential equation. The first step we need to do is put x is equal to e raised to z. Okay. With this, what are the replacements? X into d will be replaced by simply d. X square d square will be replaced by d into d minus 1. That's it. We just have two derivatives there. Okay. So first of all, write down the given differential equation. That will be x square d square minus 3x into d plus 5 bracket complete y is equal to x square sine of log x. So x square d square, according to our substitution, this will become d into d minus 1 minus 3 x into d will become simply d plus 5 y is equal to, what is x? X is e to the power z, so x square will become e to the power 2z sine of, what is log x? Log x is nothing but that. Clear to everyone?
Yes, sir.
Now simplify this. So this will be d square minus d minus 3d. That will become minus 4d plus 5y is equal to e to the power 2z sine z. So there can be MCQs like this. Convert the given Cauchy's linear differential equation to a linear differential equation with constant coefficient. Okay. So this type of MCQs can be there. So in that case, what you have to do is you have to do this approaches by substitution and identify the new differential equation in the given options. Okay. Now how to solve this? By a regular method. What is the auxiliary equation here? Auxiliary equation is d square minus 4t plus 5 equal to 0. The roots for this are, anyone? I don't have the answer for this. Please tell me.
So just a minute.
Yes.
So 2 plus I and 2 minus I.
2 plus minus I. So depending on this roots, what will be the auxiliary solution? Try this. This is a very important and another place where a silly mistake can happen. So is Samadhi.
So C1 cos Vx would be
T1 cos of imaginary part. Cos और sin के साथ imaginary part आता है. What is the coefficient of the imaginary part here? 1.
Sriracha.
1.
Oh yeah,
हाँ.
one.
T1 cos of
1x
1x
plus C2 sin 1x, the whole bracket into e raised to 2x.
e raised to 2x. Now, this answer is a bit correct, but a bit wrong also. And the reason is, original differential equation में क्या था? dy by dx. Then, while explaining you the proof of this, I explained that you were having e raised to z. So x into dy by dx किसमें हो गया change? That was changed to dy by dz. So this is your new d. I mean ये जो d यहाँ पे आया है, that is derivative with respect to z. x तो कहीं पे है ही नहीं. So your solution should have x or not, or if not, then what has to be there? तो अगर dy by dx है तो फिर you were writing c1 cos x plus c2 sin x. और अगर dy by dz है तो तुम क्या लिखोगे यहाँ पे?
C1 e raised to minus z.
c1 e raised to minus z. Why minus z? So wherever x you were writing, if your derivative changes, the originally derivative was with respect to x, तो तुम्हारा solution ऐसे आता था. Now in this case, as you have changed the variable here, you have dy by dz. So wherever you have x, you put z now.
C1
So
cos 1z plus C2 sin 1z.
yes, so c1 cos of z, c2 sin of z, e raised to 2z. So this will be the change. Okay. तो ये याद रखना है कि ओरिजिनली dy by dx है, बट आफ्टर चेंजिंग द वेरिएबल दिस न्यू d इज dy by dz. तो सॉल्यूशन में z आएगा, x नहीं आएगा. नाउ इन दिस we can resubstitute the value of z. So yc is equal to c1 cos of e raised to z plus c2 sin of, oh sorry, what is z? The value of z is log x. So c1 cos of log x plus c2 sin of log x in bracket complete e to the power 2 log x. So you can use the properties of log and this will become log of x square. E to the power log of x square. This will become e to the power log to the base e of x square is simply x square. Okay, this is the property of log. So I will change it here. We'll write down x square. Okay, so this becomes your auxiliary solution. So when we have Cauchy, we have to be a bit cautious about the variables, about writing a solution. Only then you can reach up to correct answer. Clear?
Yes, sir.
Now, the solution doesn't end here. We have to also talk about the particular solution as we have solved. So yp, you can use any of the method here. Okay. To find out the particular solution, you can use variation of parameter or shortcut method. But which is easier? Shortcut method is always easier. So first of all, look at the right hand side and decide for yourself. Can you use the shortcut method here? Do you have any case which will be applicable for this? can you identify some of the case which will be applicable to find out the particular solution using shortcut method? Do you have any rule? Anyone? Darshan?
Yes, sir. Fifth rule, I guess, or sixth one.
Yes. So exponential shift will be good here. So because you have e to the power z into v. Okay. So when we have 1 upon 5 of d, I'll take e to the power 2z outside and go for the solution. Okay. So exponential shift is workable. So that's why I am going for shortcut. Look, it will be very much difficult task while solving examples for you. Yeah, I should solve it by shortcut method or I should go for particular. So this is the idea that you have to use. You look at the right hand side and decide, okay, can I solve this using shortcut method? Is some of the case working here? If it is working, go for shortcut or else directly switch to particular variation of parameter. So yp is equal to 1 upon d square minus 4d plus 5. You have e to the power 2z sine. So by our exponential shift case, I can take e to the power 2z outside. When I take e to the power 2z outside, d has to be replaced by d plus 2 whole square minus 4 into d plus 2 plus 5 sine z. So we need to simplify this. 1 upon d square plus 4d plus 4 minus 4d minus 8 plus 5 sine z. Now this will be plus 4d minus 4d will get cancelled out and e to the power 2z. I'll have 1 upon d square plus 1 sine z. What is the rule for sine z?
So d square, replace d square by minus a square.
So what is a here? A is 1.
1 minus 1.
So minus 1 plus 1 it will become 0.
0.
So
So we have
what
to
do we?
take derivative.
We have to take
Multiply
the
by x and take derivative.
यहाँ पे किससे मल्टीप्लाई करोगे?
X.
ये d by dz है.
Sorry, sir.
So we'll multiply by
Z.
z. Derivative of this is 2d sine z. Very good. So yp is equal to, so 1 upon d is nothing but integration. So z e to the power 2z integration of sine z is minus cos of z divided by 2. This is your yp. Is the solution complete? No, because we have to eliminate this z also. Put the value of z. Z is nothing but log x. Okay, so I'll rub this question and I will put the value of z over there. So resubstitute. Z is equal to log x. So your yp will become minus log x into e to the power 2 log x
Yes.
into cos of log x divided by 2. So e to the power 2 log x will become x square minus log x cos of log x to x square divided by 2. This is your final yp. Okay, so you have YC, you have YP. Now you can combine and you can declare the solution. Any problem here?
सर वो शॉर्टकट मेथड का सर वो हम वो D+1 यूज करते हैं ना सर, वो फिफ्थ रूल के हिसाब, तो इधर D+2 कैसे है सर?
तो D+1 नहीं है, जो भी तुम बाहर लोगे, आई मीन यू आर टेकिंग e⁻²z आउटसाइड, तो जो वेरिएबल का कोएफिशिएंट क्या है, 2 है ना, दैट्स व्हाई आई हैव रिप्लेस्ड बाय D+2। मतलब वो केस में ऐसा नहीं है कि D+1 ही रिप्लेस करना है हमेशा, जो e के पावर में जो नंबर दिख रहा है उससे रिप्लेस करना होता है। मैं क्लियर?
यस सर।
It is not always D+1. Whatever is the coefficient of variable in power of e, that is to be added to d. Okay. So Legendaries is also not much of a, I mean, different from this. It is also of the same type of substitution. So Legendaries linear differential equation. So an equation of the type n ax plus b raised to n dn of y upon dx raised to n minus 1 plus an minus 1 ax plus b raised to n minus 1 dn minus 1 y by dx raised to n minus 1. This will go up to a1 ax plus b dy by dx plus a naught y is equal to f of x, where an minus 1 an minus 2 up to a naught are constant. Is called Legendaries linear differential equation. What is the difference in Cauchy's and Legendaries? You have the definition for Cauchy. What is the difference between Cauchy and Legendaries linear differential equation?
So here there is ax plus b raised to power n.
Yes, and in that there was simply x raised to n. Okay, but it doesn't make a lot of difference, because if you put a is equal to 1 and b is equal to 0 in this, what you will get? An x raised to n dn of y x raised to n. So which one is the general case in this? So Legendaries linear differential equation is actually just the generalization of Cauchy. So Cauchy just talks about x raised to n, but Legendaries talks about ax plus b raised to n. So if you put a equal to 1 and b equal to 0 in Legendaries linear differential equation, you will get Cauchy. Okay. So if you study Legendaries, you can solve Cauchy also. what is the idea? There you were substituting x. Here I will substitute ax plus b as e raised to z. Again, one and the same thing. Substitution is same in both Cauchy's and Legendaries linear differential equation. Now, what we did there, differentiate this with respect to y. So we'll have a into dx upon dy is equal to e to the power z dz upon dy. Take the reciprocal, 1 upon a dy by dx is equal to 1 upon e to the power z dy by dz. Adjust the terms here. To adjust the terms, e raised to z on the other side will become ax plus b dy by dx is equal to a into dy by dz. I hope this is clear. Ax plus b. So e to the power z goes on the other side, and I have resubstitute the value of e raised to z. Okay. So in this case, ax plus b into d. This is replaced by simply a into d. Am I clear, or is there any doubt? So in Legendaries, this a will create a problem. Again, a point where you can make some silly mistakes, and the point is when you have ax plus b raised to n, in that case you have to consider this a. So what will be ax plus b? D square will be replaced by
A. So the whole will be replaced by
a square d into d minus 1. Similarly, ax plus b cube d cube will be replaced by a cube d minus 1 d minus 2. So this is what the changes we have to do in Legend. So difference in Cauchy and Legender is about this a and b. So in Legenders, ax plus b d is replaced by a into d. Ax plus b square d square is replaced by a square d minus 1. Ax plus b cube d cube will be replaced by a cube d minus 1 d minus 2. Clear? So we'll solve one example on this immediately. A small example just to clear our understanding. Solve one plus x whole square d2y by dx square plus 1 plus x dy by dx plus y is equal to 2 sine log 1 plus x. Just be quick with the substitutions. What is the substitution? Abhishek,
Yes, sir.
what is the substitution here?
सर उसका ऑक्सिलरी इक्वेशन निकालना पड़ेगा ना सर पहले,
नहीं,
तो फिर सर 1 स्क्वायर डी इंटू डी माइनस 1 इसमें जाएगा सर वो पहला वाला.
माय क्वेश्चन इज सब्स्टिट्यूट क्या करना है?
सर ए स्क्वायर।
नहीं,
सर ax plus b is equals to
what is ax plus b here?
1 plus x सर,
हाँ,
वो सर e raised to z आएगा।
1 plus x is equal to e raised to z. Now, what is the value of a from this? You can understand. Ax plus b. What is the value of a? A is 1. B is equal to 1. Okay. So, 1 plus x dy 1 plus x into capital D will be replaced by a into d. A is 1. So, this will be simply d. Similarly, 1 plus x square d square will be replaced by a, that is 1 d square. Clear? So now, first of all, convert it to our standard form, 1 plus x whole square d square plus 1 plus x into d plus 1 bracket complete y is equal to 2 sine log of 1 plus x. Now in this we are substituting the above things. So this will become, oh, again this is wrong that I have written. Has to be d into d minus 1. So this will become d minus 1 plus this term is d plus 1 y is equal to 2 sine, what is log of x plus 1? What will be log of x plus 1? You send this e on the other side, it will become log. So sine of z. So this is d square minus d plus d will get cancelled out. So d square plus 1 y is equal to 2 sine z. The auxiliary equation here will be d square plus 1 equal to 0. So d is equal to plus minus I. So yc is equal to c1 cos of z plus c2 sine of z. Resubstitute the value of z. c1 cos of, what is the value of z? Log of x plus 1 plus c2 sine of log of x plus 1. We got the auxiliary solution. With that, we need to find particular solution. I can see the right hand side and I have the rule for sine z, so I will go for shortcut method. Yp is equal to 1 upon d square plus 1 2 times sine z. So 2 will come outside, 1 upon d square plus 1 sine z. D square is to be replaced by minus 1 here. Minus 1 plus 1 will become 0. So case of failure, take the derivative. Okay, so this 2 will get cancelled out. Derivative of sine z minus cos z. Sorry, integration of sine z is minus cos z. Now resubstitute the value of z. So yp is equal to minus log x plus 1 into cos of bracket log of x plus 1. This is a particular solution. So the final solution y will be equal to yc plus 1. Any difficulties?
सर वो yp का फिर से एक्सप्लेन कीजिए ना सर।
क्या समझ में नहीं आया बताओ।
सर वो पूरा प्रोसेस बोलो ना एक बार।
पूरा प्रोसेस नहीं, कुछ तो ऐसा होगा ना जो समझ में नहीं आया।
सर वो डी स्क्वायर प्लस 1 के बाद सर वो 2D किधर से आया अचानक?
कैसे आएगा अब सोचो। अभी यहाँ पे क्या करना था हमें बताओ। व्हाट इज द रूल फॉर साइन जेड, टेल मी। साइन एक्स अगर था तो हम क्या कर रहे थे? व्हाट वाज रिप्लेस्ड इन शॉर्टकट मेथड व्हेन वी हैड साइन जेड?
Sir,
साइन
A.
एक्स। लेट इज दर्शन आंसर। दर्शन स्मार्ट है पर वो क्या पता है, तो बीच में भूल जाता है छोटी छोटी चीज। दर्शन, व्हाट इज टू बी रिप्लेस्ड? When we have sin x, what is to be replaced? What is the rule? दर्शन,
यस सर।
हाँ sin x में क्या रिप्लेस करते हैं हम?
सर ए से रिप्लेस कर सर, माइनस ए से, माइनस ए स्क्वायर से।
हाँ, so what is your a here?
सर यहाँ पे ए एक्स
z के साथ क्या है? 1, so d
1
square
1
is replaced by minus of 1 square. पूरा चेंज करो करो, -1 + 1 क्या हुआ? ये 0 हो जाएगा, है ना?
हाँ सर।
तो 0 अगर हो
तो
तो क्या?
डेरिवेटिव सर।
हाँ, तो डिनोमिनेटर का डेरिवेटिव क्या आया? d square + 1 का डेरिवेटिव है 2d, है ना?
यस सर।
हाँ, और ऊपर z। अब ये 2 कैंसिल हो गया, 1/d क्या है? इंटीग्रेशन है, तो इंटीग्रेशन ऑफ साइन जेड आ गया माइनस कॉस जेड। ठीक है, क्लियर हुआ?
यस सर।
हाँ, ठीक। Okay, so that's all for today. We have actually completed our first module. In the next lecture, we need to start with the second module. So before that, we'll solve some more example, 1 or 2 examples on this Cauchy Legendaries, just for understanding